Characteristics of electromagnetic waves. These waves have no charge and so these are not affected by electric and magnetic field. These have the speed 3 into 10 to the power 8 meter per second and their nature is that of a transverse wave, unlike sound which are longitudinal in nature. They can be polarized. Polarization is possible with electromagnetic waves only because it is transverse and they also affect the photographic plates, but the condition for that is their frequency needs to be greater than that of infrared rays. Their frequency doesn't change when the medium is changed. They transport momentum with them. It simply means when they are left on some object, light object, they are capable of applying the pressure on that thing. They carry energy, and this is very interesting that electric and magnetic, both the vectors, carry equal amount of energy. Energy density. Energy density could be given by 1 by 2 epsilon naught E RMS square. This is energy density. By energy density, we mean energy per unit volume. You always remember that energy density is equal to the pressure dimensionally. Dimensionally, the energy density will always be equal to pressure. So, numerically also we can use this relation that energy density will be equal to the pressure involved. If you replace this value ERMS by E naught upon root 2, you could write it as this epsilon naught E naught square 1 by 4 epsilon naught E naught square. Similarly, if we want to write in terms of B magnetic field, it's going to be this relation or even 1 by 4 this B naught square upon mu naught. You see, we have given the energy density because of electric field and because of magnetic field. Interesting is that these both are equal. Both are equal. And total energy density will be given by the sum of the two which are equal. So you could say this is going to be 2UE multiplied by 2. What you get is half epsilon naught E naught square. This is the energy density total. And the same thing you could say in terms of magnetic field also, it will be half B naught square upon mu naught. You see, this is energy density because of both the field or both the vectors is going to be equal. And for finding the total energy density, you'll have to sum up or you just say that it is going to be twice of any energy density, electric or magnetic. Then finally, what's the radiation pressure? You see, it's very interesting when solar light falls on the earth, it applies the pressure on the earth. It's 4.5 into 10 to the power minus 6 Newton per meter square. The pressure is quite, it's not ignorable, you see, you'll have to consider its value. So, radiation also applies the pressure. When electromagnetic waves fall on some surface, they are capable of applying the pressure. You see, energy of a photon is given by mc square and m into c, that is momentum, could be given as E upon c. When these photons will fall on black body, they would be simply absorbed. So you could say the transfer of momentum on the black body is equal to E by c, and that on the reflecting mirror, perfectly reflecting mirror, it's going to be 2E upon c. Why? Because mirror will simply rebounce the photon, and rebounce means when it came, it had the momentum E by C. When it returns, it will have the momentum minus E by C. You find the change, that means from minus E by C, you'll subtract plus E by C, and you are going to get finally minus 2E by C. So, change in momentum will be equal to minus 2E by C. That's why I said that when it falls on perfect mirror, the transfer of momentum is going to be 2E upon C. You see, the intensity is given by energy per unit area per unit time. This could also be written as, you see, I have multiplied and divided by length. Now what becomes E C, length upon time is velocity, and area into length is going to be volume. Energy per unit volume is nothing but energy density. So this is one important relation. Intensity is also equal to energy density into speed of light. That's what is written over here. This intensity is energy density into C, and energy density is equal to pressure. This could also be written as energy density. This is equal to pressure also. So, pressure on any object is going to be I upon C. Whenever the electromagnetic waves fall on some surface, the pressure is going to be I upon C if it is a black body, and if it is perfect reflecting mirror, then it will be 2I upon C. 2I upon C on perfect mirror, I upon C on black body, and momentum transfer I have told you. This is E upon C and 2E upon C.